So the next question has been obtained from area approximation, and we've been given a graph here that I'm supposed first to sketch and then get the area of that shaded region. So you are told to have this as your sketch as per what the question has given us. Obviously, as a Cartesian plane, this is the y-axis and this is the x-axis. So you've been told that this has to move out to this end and this extends upwards. And you're told the whole of this is a shaded region of this drawing. And this arrangement has had this as y is equals to x squared, and the other one, or this other curve, is given the equation y is equals to 8 minus x squared. And I'm told that at this point of intersection, the value of x is 2. Yeah, I'm told to get the area of the shaded region. Now, you see, it is very important that you know that whenever you get a question that talks about getting the area of the shaded region, and that shaded region has been enclosed by two curves, I have been told to get the area of the shaded region, and the shaded region has been enclosed by two curves. What do I do? This is the first curve, and this is the second curve. To realize that this shaded region has been enclosed by those two curves, I need first to come up with what we call a standardized equation that can help me get the area of this shaded region. I have to come up with what we call a standardized equation that can help me get the area of this shaded region. I know the first equation reads y is equals to 8 minus x squared. And the second one reads y is equals to x squared. So that means I'll just take the first equation, then equal to the second equation for me to get what we call a combined equation that can help me get the area of this region. Because if these two curves intersect at point 2 as the value of x, and they have actually enclosed a particular region with the y-axis, what do? I know at this point the value of x is 0. So at this point, you're supposed to get the area that is enclosed by the y-axis. Y is equals to x squared, and y is equals to 8 minus x squared. Because these two curves are enclosing that shaded region with the y-axis, then I'm supposed to take the first equation equal to the second equation so that I can get the area within that region. When those two equations are able to intersect, then enclose that area with the y-axis. So I'll just come here and say 8 minus x squared should be equal to x squared. Why? Because I know this is y and this is also y. So y must be equal to y. So I just take the first expression of y, I equal the second expression of y, and see what's the combined equation of that. So I'll take this onto this other side. So I'll have 8 minus x squared is equals to 0. So this translates into 8 minus 2x squared. The answer must be equal to 0. So this is a quadratic equation that represents the area within the enclosed region. And I'm supposed now to use this to be able to get the area within that enclosed region. And of course, I can use what we call integration method. So I'll just say integrate. Okay, so integrate 8 minus 2x squared with respect to change in x. And of course, the limits are 0 and 2. So I'll have 2 here, then 0 here. So I need to get the answer to this by first integrating, and then I have an input of 2 and 0 as the limits within which I'm supposed to work in terms of getting the area. Then I'll be able to get the area of the shaded region between those two curves after they have intersected and have actually ended up enclosing the area shaded here with the y-axis. So what is the integral form of this? So the integrated part of 8 minus 2x. So I just say 8. When you are integrating, if there's a constant in what you want to integrate, please introduce a variable x. Then less 2x squared. Please increase the power by 1 and divide by the resultant power. That's now what you are doing in terms of integrating. So you have 8x less 2 over 3 x cubic. Okay, so you have this, and the limits are 2 and 0. Do I need to even use 0? No. Let me just place 2, then I'll be able to get the answer in terms of the area of the shaded region. So I'll just come here and say 8 into 2 as the value of x minus 2 over 3 into 2 cubed. Correct. So this will be 16 less 2 over 3 into 8. That is 2 cubed. So we shall have 16 less 16 over 3. That is 2 over 3 times 8. So 16 times 16 over 3. So 16 minus 16 over 3. That gives us 10 and 2 over 3. So the area of the shaded region is 10 and 2 over 3, and I'll write square units. That becomes the area of that shaded region as per what the curve has given us in the question.